This is where we look at diodes. Now, the symbol for diode, you may remember from level 1, is like that. Now, a diode has to be placed in the direction in which you want current to flow. So the arrow gives you an indication that it goes from positive to negative. So if we had this diode hooked up, we'd want this to be positive, and I don't know, maybe that's a lamp, and that's the way we'd hook up the diode, positive to negative. And on the actual diode, physically, you normally have a band, and so you'll point that towards the negative or away from the positive. Thing about diodes is they allow the current to flow one way. That way. The direction of the arrow. Which is okay because that is actually the way the current flows. So this light would lamp if this lamp would light if it was hooked up that way. But if we hooked up our diode this way, this lamp isn't going to light because the current wants to go from plus to minus, but it can't because the diode's hooked up the wrong way. So it won't let it flow. This lamp would light, this one wouldn't. So what you've actually got is you've got a very low resistance this way and a very high resistance that way, and that's what these diodes do. So they allow you to control current and the direction current flows in. The use that we put these diodes to, obviously to stop current going back another way. We often use them in transformers. We haven't used a symbol for transformers, but when you've got alternating current, which we look at more in year 13, we've got a voltage that goes up and down. And what we want to do is we want to get a voltage that just stays constant. And so we put them through 4 diodes called a rectifier bridge. And what happens is we end up getting, so this could be our load, we end up getting these 4 diodes here. They control the direction of the current and enable us to get direct current out of alternating current. I won't go into that except to say that the little 4 diodes are sort of in here like this and like this, and so we've got 4 of them in here and they control the direction. So diodes are very commonly used in that. It's called a rectifier. They also, there's a few questions on them. If we look at resistance, stuff like that, I said the resistance one way was very high, right? Now this brings us just into Ohm's law. Remember, V equals IR is Ohm's law, and we said that in a normal ohmic conductor, then the resistance is constant. So if resistance equals V over I, which it does, and we have V over I, then that's the sort of graph we'd expect, a straight line, where the gradient is the resistance, right? Rise over run gives us the gradient, which is the resistance, and that's a nice straight line. But something like a light bulb, a tungsten filament, what happens is the resistance gets higher as the voltage is increased. So something that does that is more like that, right? So current's increasing, voltage is increasing, and the gradient is increasing. Gradient increasing means increased gradient implies increased resistance. And that's what a light bulb does. It gets hotter. Usually it's heat that will do that. All right, so that's one of the things we have to think a little bit about. Now, I think with the diode, we found, what was it, at a certain voltage. Let's see if we can draw a little graph. At a certain voltage, we would have 0 current, usually about 0.6 volts. So we pretty much, if that's current and that's voltage, like these graphs here, we pretty much have very little current up to there. And then suddenly, as the voltage is increased, it goes like that. Right? What's happening here is, oh, after a certain voltage, it turns on and it's actually got quite a low resistance, and we get a nice current flowing. So that's the little resistance graph for a diode. Could we turn that around? I suppose you could do it. You could do it around a different way, where you've got voltage against current, and again up to about 0.6 volts, nothing, and then suddenly it starts to, so it cruises along and then it goes up. And again, this I over V, the inverse gradient of this would be the resistance of the diode once that actually happens. But your voltage drop across a diode, okay, so you'll see various graphs looking like that in questions. When you've actually got a diode in a circuit, for example, like this, (12 volts). A lot of diodes will actually have a voltage across them of, so if we measure the voltage from 0.2 volts to 0.6 volts. So if that was 12 volts and this was 0.6, then this lamp could only have a voltage of 11.4 volts, right? But in answering your questions, make sure you look at the data they give you. Don't just assume that that's going to be 0.6 volts. They might, for the benefit of your question, say, okay, maybe this time there's no voltage. I know it seems silly, but sometimes using the real values would make the question too complicated. So that's a little bit on diodes.